Hey everyone, so this is going to be the last video about pointers, and this is like the finale, but honestly I am still not sure whether this concept is making sense to you or not, but again I'll try my best to make sense of it. And if you have any sort of questions or stuff like that, you can ask me. So yeah, let's get started. Pointers are also used in C to enable function to modify a variable held by the caller. Okay, so we already seen that like whenever we want to change a variable from outside the function, we saw in the swap function, the previous lecture, that over here we are sending these two values as t mean and t max, and we are setting the value to the first parameter of first index of this one. Okay, so one thing to notice over here is this is an array, but these are values. So how do you make differentiate, like how do you differentiate between them? You cannot. So that is one of the biggest problem with pointers. Like there is no indication whether that is an array or that is a variable. So whenever you are using pointer, you have to use some sort of caution. For example, in this case, we are setting it to const, so that whatever array is being sent here, it cannot be changed. Okay, only these two are being changed. So in this case, we know that it is an array, but most of the time we will have no idea whether we are sending an array or a pointer of a variable. For example, this one and this one looks almost the same. So how do you differentiate them? There is no way to do that. Usually you will see that some sort of comments are written on top of the function. Remember, I have been telling you to put comments in your code since the beginning. So before you implement a function, the first thing you should be doing is write a comment about the, like before the header, so that whoever uses the function has an idea of how the parameters work, whether you are supposed to send an array or you're supposed to send a variable. Okay, so this is a very straightforward function. It is in the GitHub link, so you can download it and try it by yourself. So at first we are basically setting two values, then we are going through the array. In this case, we send the size, and then we are checking whether it is the maximum value or minimum value. And in this case, we don't have to do any sort of return. So one important point over here is whenever you are in a job interview, you will be asked in C, is there any way to return multiple values? The answer is technically no. Also, the answer is yes. And how it works is, yes, you can actually make sure that multiple values are returned. This is what you do. You send the function, like you send the addresses of them as parameters. So in that case, when the function returns, the values are something new. So technically you return the value, okay? Another way is to use structure, which we will see soon enough. So yeah, after this course, you will be adding C as a language you already know in your CV. So in the job interview, this is a question most of the time is asked, like, can you actually send multiple values from in C? The answer is yes. You can use either pointer as a parameter, or you can use structure, okay? So if we call it, and we will see that these two values are changed. They will have the minimum and maximum values respectively. You can give it a try to print the values and see what happens, okay? So returning a pointer. So whenever you're returning a pointer, make sure that you always return an address, okay? Always go for this. And because like when you are doing a malloc, this address, like this allocated memory is going to persist, okay? So even though you go outside the function, it will not disappear, okay? So whenever you're returning some sort of pointer from a function, make sure that you are dynamically allocating it. Okay, give it a try and see what happens. Never go for this, only villains do that. Because like if you do that, remember this local function has the scope of block scope. So whenever you get outside of this block, it stops existing. And as you can see, there is no static over here. So if you return the value like this, like you are returning the address, it will work initially, but after 2 or 3 lines, it will stop working. And you should never do this, okay? Give it a try and see what happens. Write 2 or 3 more lines after this and see whether it fails or not, okay? Sometimes it will give you a very weird output. Sometimes it might even give you segmentation fault. So anything might happen. So whenever you are returning a pointer, make sure you allocate memory for it. You never use a local variable's address as a return, okay? Pointers and const. So this is a very important aspect. You should probably like print it out and put it on your wall just so that you do not forget about it. So const can be applied in interesting ways in pointer contexts. So this is a normal pointer declaration, right? Pointer and target both can be changed, okay? This is const int pointer p. Pointer can be changed, target cannot, okay? So in this case, what it means is, so what it means is it cannot change what it is pointing to, okay? So it is going to be somewhat like an array. So if it starts pointing at the beginning of the array, that's where it stops. It cannot move from there. This is target can be changed, pointer cannot. Okay, so the pointer can point to somewhere else, but it cannot change by itself. And then there is the const int pointer, const pointer. Neither pointer nor the target can be changed. Okay, so in the latter two cases, unless you are declaring a parameter, you must initialize the pointer in its declaration. So if you do not do that, you cannot use the pointer at all. This provides safety against inadvertent changes to a pointer or its target, and is certainly an underused feature in C. Well, most of the cases you will not see this happening, but it is something important to know. Like over here, if we do that, it cannot change at all. In that case, you have to use a array notation. You cannot move it at all. And in this case, p means value. Okay, so with this target can be changed. It means that it can be changed by doing a dereference. When you are doing a dereference, you are basically using the variable, right? So in that case, the target's value can change, but the pointer will not change. It will always point to the same thing. But in this case, pointer can be changed, target cannot. In this case, you cannot do this. It will give you an error. You can do something like p main equals some other variable. That's going to be okay, but this is not okay if you're doing this, okay? Try to run this by yourself and see what happens. Using const with pointers. Here's an improved version of the find extrema. We already did that. And in this case, we are making sure that the PA never changes. So even though we are sending an array, it cannot be changed, like neither of its value or the pointer it is like where it is pointing. In this case, p mean whatever value it is holding can be changed, but p mean will always point to a certain variable. So it is good in a way, because in this case, p mean cannot be made to point to something else. So whenever you get outside, it is still pointing to the same thing. So that particular variable's value is changing, not the pointer. Like the pointer is not pointing to something new completely. Okay, so now the function cannot make PA point to anything else, nor can it change the values in the array that PA points to. Now the function cannot make pmin or pmax point to anything else, but we do need to let it change the values of the targets of pmin and pmax. So void pointers. So this is something of a new concept, but you already have seen that in the string lecture. So this is more of a formal definition. Okay, in C, a pointer may be declared of type void. So what type void means is it didn't specify, you didn't specify any particular type to begin with. So target can be of any type. So no compile time type checking occurs. Void pointers are not useful in many situations. The return value from malloc, sorry, well, the return type of return value of from malloc is actually void pointer. They can be used to achieve generic programming, often data structures, but also a number of useful functions. So I don't know why it said not useful. Pointers are useful in many situations. Okay, so by specifying that a variable is a void pointer, you are basically telling the compiler that I can turn it into anything I want. And that's how the compiler is going to work with. So in void pointer, you can actually typecast it to be any type of pointer. So whenever you're doing a malloc, in most cases, we are not doing a typecasting because C kind of does that directly by itself these days. But if you use the older standard of like C89, I'm not sure if it's the same in C99 as well. In C89, if you try to do malloc directly without typecasting, it might give you an error. It will say that the type mismatch. So typecasting is necessary whenever you're using void pointer. Okay. So we already saw memcopy, and in memcopy, the parameters are void pointer. They are not integer or character or whatever. That's why memcopy will work with everything. The memcopy function copies n characters from the object pointed by S2 into the object pointed by S1. If the copying takes place between two objects that overlap, the behavior is undefined. Returns memcopy function. The memcopy function returns the value of S1. So over here, memcopy can be used for everything, and that's why it is a void pointer. So it is more generic, right? Now, the most difficult topic of pointer. So pointer itself is a difficult topic. Pointer of pointer is difficult topic of a difficult topic, okay? So a pointer can be pointing to a pointer. One use of this is to pass a pointer so that a function can modify it, okay? So over here is a pointer of pointer, and it has the size. So usually, well, this is not a convention. Sometimes people will be bad programmers and they will not send a size. But if there is a size, you can assume that it might be an array. But most of the time, it may not be an array. Okay, so there is no actual way to specify whether you are sending an array or a variable. Anyway, so we are creating a malloc for this P, and it's going to be an array because we are creating a dimension of size. Then we are checking whether it was allocated or not. If it was, then we are going to put value of 0 in its indexes. Okay, so in this case, we actually have a pointer, and then we are sending that pointer's address so that that specific pointer can be modified. Okay, so if you just send array itself, it would for some reason be a okay, so this is how it works. I'm trying to think how to make sense of it. Okay, the concept is similar to this. So in this case, is it? Yeah, in this case, we were saying that if pmin started to point to something else, there would be a problem because it is supposed to be pointing to the variable that was sent as a parameter. Okay, so even in this case, it would be the same case because think about it. If we sent array like directly like this, okay, if we sent it this and over here array is a pointer of something, then we are doing this instead of like not double pointer, because in this case it will be a single pointer. We do something like a equals malloc. Now think about it. This malloc is going to start pointing to something different, like something completely new. It's not going to start pointing here. So this is how it works. You have a array pointer. Okay, so this is what you have, and then you are sending it to the function. So the function itself has this. Okay, it is pointing to a null because it didn't initialize to anything. Let's assume it's pointing to null. After it comes here, then this A would start pointing to something else, not this array, if we didn't do a pointer of pointer. But by sending a pointer of pointer, we are making sure that this one is pointing to an array. And that's why you need pointer of pointer whenever you are working with an array, and you need to make like dynamic array basically, not a static array, because static array cannot be changed and so on. So this is why you need it. And I don't know if it made sense. I don't know how to make it more clear, but this is all I have. So if you have still confusion about it, ask me about it. Dereferencing a pointer. We said earlier that dereferencing a pointer is the target of the pointer, but there is a bit more to that, and the C standard says that if the operand P points to an object, then the result of star P is a L value designating the object. If the operand P is the type of pointer to type, then the result of star P has type. And L value is an expression that potentially designates an object. So pointer casts. So this is the, this might be a bit confusing, but try to follow me and maybe it will make sense. Pointer typecasting can be used to define the amount of data dereferencing yields. Suppose that you run a program and give it your PID as a parameter. Okay, then suppose the code in main does this. So you have a limit, and over here argv1 is this. I don't know whether it's the case. So let's see. Over here, this is the program name, and this is the PID of Professor McQueen. So if we do something like this, and whenever we're running it, argv0 is having program, and argv1 has McQueen. So what's going to happen in this case is if we typecast argv1, okay, remember that argv1 is a character pointer, right? So it is a string, and it has McQueen. Okay, the pointer cast takes the pointer argv1 and produces a nameless pointer of type uint32. Dereferencing the pointer yields 4 bytes of the data. Okay, so over here it is actually creating a temporary pointer of the type this. Dereferencing the pointer yields 4 bytes of the data because the target of uint32 is 4 bytes in size instead of 1 byte, which is a character. Okay, so if we dereference it, we have 4 bytes instead of 1. So it's going to have this, 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 and this. The final typecast tells the compiler to interpret those 4 bytes as representing an unsigned integer value. So all 4 of these are going to be considered as one integer. And this is what the value is going to be. And actually the value is going to be inverse. Okay, that's because of big endian settings of C, which you will see in the assembly. Okay, so yeah, try to do it yourself. Write a code where you just like do this particular typecasting with your PID and see how it looks like. Okay, so here is a better visualization. So suppose the pointer P points to the beginning of the memory region. So over here. So if we do a typecasting with like 1 byte, which is 8 bits, it's just going to print this. Okay, but if we do a typecasting with 2 bytes, it's going to take both of them. If we do 4 bytes, it's going to take 4 of them. And if we do 64 byte, it's going to take 8 of them. Okay, give it a try yourself and see what happens. So what does typecast really do? So we know that if we have a double and if we typecast it to integer, it just like cuts off all of this and only has this. Okay, this creates an anonymous nameless variable of type int initialized by converting the value of x into an int. The anonymous variable ceases to exist after the computation it is used in is completed. The cast has no effect on the value of the variable being cast x. So x is not going to change. It's just going to create a temporary variable over here and put the value in a. So that's it. That's it for pointer and typecasting. If you have any confusion about it, ask me. I will be delighted to help you out to understand the concepts. Okay, I am expecting questions from you, but like literally nobody is asking me questions, and I don't know if I'm doing it wrong or everyone is super smart, which is really good. So yeah, if you have any questions, let me know. I'll see you in the next video.